Welcome to Emtron Training Part 15. In this training tutorial, we're going to be taking a look at the relationship we have going on between our airflow and fuel modeling strategy within the Emtron system. Now, we have to understand this basic underlining type of concept. So when we're going into working with something like speed density or mass airflow or throttle mass flow for airflow type of strategies and doing our calibrating and tuning, we understand what's going on and how the fuel model fits into that airflow modeling relationship. This basic understanding will carry a long way into properly calibrating and tuning with your Emtron system. So we're going to be digging into all of this in this training tutorial. Let's jump in so we can check this out. Okay, so let's get started. We're going to be taking a look at the airflow and fuel modeling relationship that we have going on within our Emtron ECU. We have to understand this relationship so that when we're moving into our calibration process, either going into our fuel modeling side or the airflow modeling side and making changes, we're understanding what those changes represent and why we're actually making the changes. This is going to allow us to have kind of a high level type of look at what is going on with the Emtron and really understanding the fundamentals. If you don't understand these fundamentals, going in and making changes into the tables, changing the values, is really arbitrary. We want to understand what these values actually represent and why they're so important and why we want to change maybe one type of a value over another. So the first thing we need to understand here in exposing and taking a look at what is going on with our airflow modeling strategy and fuel modeling strategy is understanding the fundamental equation that ties both of them together. We have fuel mass is equal to air mass divided by target air fuel. This is going to be how we convert the estimated or measured airflow as it's coming into our engine with our Emtron. And we convert that into an injector pulse width that we spray the fuel into our engine and that we hit an air fuel target that we're programming in the Emtron. So they're all going to fit together very neatly, but they all rely on having the airflow model properly and the fuel model properly. So let's break this down here into individual terms, and then we'll put it all back together and just understand the whole thing of how that equation is going to go in terms of the different areas for programming. And it's going to make a lot more sense once you get towards the end of the video. So the first thing we have, again, taking a look at our equation, fuel mass is equal to air mass divided by target air fuel. The first thing I want to discuss here is going to be our air mass. Now, air mass is something that you may not have heard the actual terminology. You probably have heard of airflow, but what is air mass? Air mass is going to be our volume times the density of air. So mass of any substance is volume times density. If we're talking about a cup full of water, we could calculate what the mass of that cup's going to be. We would know the volume of the cup and we'd know the density of water. So therefore we'd know the mass of the cup of water. If we're talking about the same cup, so we know the volume, and we fill that cup with gold. The density of gold is much different than the density of water. And we know what the density of gold is going to be. So therefore the mass of the cup is going to be different. So the mass of a cup of water or the mass of that same cup of gold, completely different densities, completely different masses associated with that. And that's something you can physically pick up and understand and know right away that one is essentially heavier in mass than the other. That same kind of concept here is going to be applying in terms of air mass. Air mass is going to be the volume of air entering our engine and the density of the air entering our engine. And the reason why we have to represent air mass instead of just airflow is because as we change our elevation or the ambient temperature changes drastically, we're going to find the density of the air changes. The density of the air is how many oxygen molecules are packed into the same given volume of air. And why that matters is because it will influence and affect what the fuel demands for the engine are going to be. So if you have an engine that's operating at 0 degrees Celsius air temperature, or you have the same engine that's operating at 100 degrees Celsius, the amount of fuel we need to inject into the engine will be different, and therefore we need to make sure we're representing our air mass properly to the Emtron so we can figure out what that particular amount of fuel we need to inject is going to be. Now, when we're talking about our air mass, we can deal with air mass representation in two different ways with our Emtron. We either have a measured air mass or an estimated air mass. When we're talking about a measured air mass, this is assuming that we're setting up the Emtron to work with a mass airflow sensor, which we do have the option to do that. The mass airflow sensor will directly measure the air mass, so it knows the volume of air entering the engine. It's also going to represent and know what that density. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.